Hello everyone. Today we'll have a look at MCRS and ABB SyncTask inside DELMIA Robotics. So we're going to have a look at a couple of different use cases and finally at the most recent use case that we support fully, which is the ABB SyncTask syntaxes and the whole infrastructure inside DELMIA Robotics. So let's jump in and look how the setup for an MCRS cell looks like. So for MCRS to work, robots or any other devices we want to control, they have to be placed under the same control equipment. And as you guys probably know already in DELMIA Robotics, under control equipment, you can deal with multiple motion groups. And inside a motion group, you're gonna have to place your robot and then any other devices like rails, positioner, grippers, and so on. Then, whenever you launch a new device task command from the programming tab, pretty much any app, any robotics app has this, you're gonna have a choice of which motion groups you want to include into your task. And as long as you put more than one motion group inside your task, you will have created a MCRS task. There is another way to do it. Let's say you already have two tasks previously defined for your motion groups. So we have, for example, task 1 of robot 1 and task 1 of robot 2 with their appropriate motions. Once you launch the same command and from the drop down from the task column, you will have the possibility to select existing tasks. Once you do that, basically an MCRS task is created for you by combining the two motions from your motion groups grouped under an MCRS operation. Then for an MCRS operation, you will have different synchronization modes, which will describe how your system how your system moves from one operation to another. And there are basically 4 different ways to achieve that. You can do it in an independent way, meaning that your timelines will be different for your two motion groups, meaning that independently robot 1 will move from motion 1 to motion 2, and the same goes for robot 2. Then you have a synchronized way of working where your robots will time themselves accordingly so that they start and finish at the same time. Then you have a coordinated motion, which is basically the example where one leader moves the targets for the other robot, and what happens is that the first robot will make sure that it follows the tags accordingly in this system that is moved by the second one. So the motion of R1 in our example will, in R2, let's say if we have 3, this is like a schema, a scheme for 2 robots and one, let's say another carrying robot, or it could be a positioner, the same thing. So the motion of R1 and R2 will continuously adapt to the leader movement, the leader being R3. And of course, you have the fourth one, which is the combination of synchronized and coordinated, which is called synchronized coordinated mode. And this can be all chosen from the teach. You have the synchronization mode column that lets you choose that for every operation individually. Okay, then let's look at a use case with two body-in-white big KUKA robots, high payload KUKA robots. They are supposed to lift this whole car body. They have a gripper each, and therefore the use case looks something like this. I create an approach task for each of the robots. Then I can combine them using that new device task panel and selecting pre-existing approach tasks to create an MCRS approach task from the two. Then I can go the other approach where I create an empty MCRS task, so by just checking the two motion groups, and then I can use the coordinated mode to teach the two robots, and we'll see that later. And then of course I can call a master task that will call the two MCRS tasks done in the two ways. So this is the coordinated mode that I was mentioning before. The whole idea is to have a way of easily selecting between who is the leader and who is the follower in a interactive way. So that's why whenever you're gonna hit this little button here, you're gonna have a jog manager launch that will allow you to make that choice. And it can be quite useful because in a load sharing use case, the reachability of a certain position will be dependent on both robots. So let's see this video. So I'm in my RobotTask teach environment. I click on my jog manager, and then I can launch from there the two jog panels individually. You saw me doing it for robot 2, then I'm launching it for robot 1. And here I can see, because robot 2 was the follower, whenever I jog to robot 1, robot 2 follows, but then I can easily switch that or turn it on and off from this panel. So it's a quite cool and interactive way of doing things. The control setup, just as I was saying previously, we have the two grippers here, which are like in the design positions, let's say, with their TCPs and everything defined. They're all relative to the car 0. Okay. Then what I go ahead and do, I go and use the set tool command, probably, yes. Okay, I put it how I want it to be. And I'm gonna check the two boxes, external axis and controlled by. That will create my control equipment for the whole cell. I do the same thing for the second robot with the same external axis and controlled by. But in this case, I will be selecting the existing control equipment so that the previous control equipment can control both robots and both grippers. So once I do that, if I go to my motion controller function here, I can see how both my robot arms and both my gripper mechanisms are to be controlled by the same control equipment. And once I go into the manage motion groups command, I can see the R1, let's say, and the R2 motion groups. There are my two robots. Okay. So my from home to the car. So I define some home position for my two robots. Okay, I use the home position command because that's quite useful. Do the same for robot 2. And then I'm launching this new device test, but I'm not doing an MCRS for now. It's just to create a two home to car tasks. So just doing a few little motions to get to the car, and then I'm gonna also use the fact that I previously had a tag that was on the car 0. I create a tag on the car 0 position that I can then use inside my task. Da-na-na-na-na. Do the same for robot 2, then include them in this task. So as you can see here, once I launch this new device task and I select a motion group, I can from this drop down select an existing task that I want to include. Call it MCRS to car, and create a new simulation state. That's also useful to have. And I can launch my two tasks, my MCRS task, and have a look at it. Da, da, da. And I have my clamps closing as well. Nice and synchronous fashion. Okay. For the scan motion, so obviously I need to pick up my car. So here I'm starting from scratch. So I'm doing an MCRS scan task. That I go ahead and jump into the teach. Inside the teach, of course, I need to grab my car. So I create a grab command, grab activity. I'm gonna grab it one of the two robots. It doesn't matter which one. Okay, and once I do that, I can start playing with the coordinated mode. Inserting an MCRS operation, then I'm inserting a tag motion, and that creates the two robot motions. Launching the jog. Okay. And so on and so on. I can teach my two robot system tag by tag. Right, just like so. Then see the result with the cable simulation included, of course. Okay. So then we see the result, of course. We have the three tasks that I can call in the same master task. Right. Grab the car, flip it over, go to the scan, do my motion here. And drop it over to the other side. Cool. Cool, cool, cool. Okay, now let's look at another use case. So this time we have two FANUC robots mounted on a 3-axis rail. They will be welding synchronously with this positioner. So here the setup is as follows. We create an arc trajectory for motion group 1. Then for the same, we create an arc task. And then we use the auxiliary axis programming function to program the gantry and the positioner. And then for the second motion group, we're gonna replicate the task that we previously created for it, and then we're gonna recalculate only the x-axis values. Then we're gonna jump in and create an MCRS task starting from the two arc welding tasks. Okay, we jump in. So the motion controller here, we have it here. So it controls arm. It creates the two gantries that we have in the system. And the setup looks something like this. So on one side, we have the arm, the rail, and the workpiece positioner. And then on the other side, we only have the arm and the rail. In this case, I had two instances of the same gantry, just FYI. Okay. And that gives me the full control to jog the robot nicely mounted on the rail. Okay. Yeah, so yeah, make sure the positioner is only one of the motion groups, otherwise you're gonna run into issues. Okay, once I have my welding task nicely set up, I can launch the replicate task across resources. So it's an easy enough command. So basically here in the first column you have the source, and then you have the target on the right side. So clearly my source is motion group 1, my target is motion group 2. my controller, this is my arm, this is my arm, this is my rail, this is my rail. Obviously on the target side, I don't have a positioner. And then I'm also going to run in, I'm gonna disable the compute rail values since I know I want to keep the same. And I'm also mirroring the targets. So once I do that, I'm gonna have my copy of lateral task that I can then jump in the auxiliary access programming. I'm selecting my operations, and as I can see, I'm in the X value. I'm quite far away from my welds, so I need to recompute the X values with the positive sign so I can be on the other side. And that's it. Okay, then I launch the new device task. I select my two motion groups and my two existing tasks, the original one and then the replicated task, let's say. And then it's as simple as running the whole MCRS task. So you can see we have a coordinated motion with the positioner, and the robots are also moving on the rail. So everything is nice and smooth and coordinated. Okay. Good, good, good. Finally, let's take a look at the ABB SyncTask and how it's supposed to work inside DELMIA Robotics. So we have a simple setup with two stationary robots and a two-axis positioner welding on the same excavator bucket as we saw earlier. So the cell setup, just for ease of use, I usually, I advise you to rename your instances, so R1 and R2 in our case, and then I'm gonna use the set tool command. Clicking the robot, clicking the welding torch, reorient it so it looks like in the photo. We check the controlled by to create the control equipment. Do the same for the second robot, and this time we select on the controlled by the control equipment for R1 that was previously created. Then in the motion controller window, we select the positioner, we switch it to yes because we want to control it as well, and we switch it to a usage type workpiece positioner. And we go in, and this time, because this is how ABB works, we're gonna separate the three. So we're gonna have one motion group for R1, one for R2, and then one for the positioner. Okay. Then for the setup, yeah, of course, your bucket needs to be attached to the positioner. Then I'm providing you with three programs, so one for R1, one for R2, and one for the positioner. So all you gotta do is to upload them following this. Yeah, so these are the three programs. And just make sure that your work objects or your object frames are attached to the gray part of the positioner, like you can see here. Okay, and then they'll be visible because then you'll see your tags being in the right place, and of course you can jog the position and you'll see the tags following the bucket correctly. Then what we do is we have a new command here called resource team lineups. So this is creating the lineups as for ABB standard. So lineups is just a group, a team. A team is going to contain all the potential robots that can be coordinated, and the lineup will indicate the specific group of robots within the team that we were calling, let's say, to freeze or to wait in a certain location. Okay, and this is how we manage coordination in ABB. So here I create a lineup called robots with R2 and R1 motion groups, and then a lineup called robots in positioner with all three of them. With the tasks that you already are provided with, we just add some location above the bucket for the two robots, like let's say a safe position. And then we're gonna create SyncTask instructions for all three devices. So what we have here is an above weld SyncTask command that uses the robots only lineup. And of course, we're gonna create it only for the robots. And then we have a weld start that's gonna use the robots in positional lineup, and that we position in all three tasks. And here the robots will move independent between the above weld and the weld start. And that is just to highlight the possibilities, because they could also, of course, move synchronously. And that's about it. And the result should look something like this. So let's jump into the teach just to see the tasks a little bit. Right, the above weld, the weld start. And all I did was play with the speed of the robots a little bit so that we can see that independent motion. So for R2, R1 is like 1,000 millimeters a second, but then R2 is slowed down a little bit, if I remember correctly. And then we have the positioner task. Oh, and also what's important is the sync ID. As you can see here, this has to match the three tasks. And in the master task is simply a parallel task calling the three of them, as you can see here, calling the three independent tasks. And once we start this, we see one of the robots moves faster but still waits for the position, waits for the other robot, and once they are all in place, the welding can go ahead and start. You can see here the tags. Gonna speed it up a little bit. Then we start the synchronous move with all three groups. Okay. And of course, this can be then downloaded. So I'm downloading only the master task, but I selected like download call tasks here. So at download, I'll have my three tasks coming up. Okay. Okay, so that's pretty much all I have. All I had for you guys today. I hope you enjoyed it, and yep, if you have any questions, you can hit me up on the community or on Skype. Thanks. Have a nice one. Bye.